In today's session, we are going to talk about your Bayesian classification. In yesterday's session, we have seen one of the classification algorithm, that is your decision tree. This is the other classification algorithm, that is your Bayesian algorithm. In your decision tree, we have seen what is entropy, how are you going to calculate entropy, and how are you going to calculate your information gain. Based upon your information gain only, the data set, you are going to draw your decision tree. Now, your Bayesian algorithm. Now, why are we using this Bayesian algorithm? It is one of your supervised learning technique. So, in the supervised learning technique, what are we doing? Basically, your supervised learning technique is all about what your classification algorithm. So, here it is your supervised learning and we use Bayes theorem for this. You all have learned your Bayes theorem already. And this is one of your text classification algorithm. Your Bayesian algorithm or Bayes theorem, whatever we are using, it is used for your text classification. When I say it as Bayes, you all can relate it to your probability. So here we use probability classifier. Now, you all can see here what is your Bayesian classification. Why are we using this? It is a statistical classifier. As I told you, we use probables like probability. So it performs what? Probabilistic prediction. That is, it predicts your class members' probabilities. Next, as I told you, we use Bayes theorem. The foundation of this is what is your Bayes theorem. Its performance. It used Bayesian classifier, that is Naive Bayesian classifier, which has what? Comparable performance with decision tree and selected neural network classifier. Like in your decision tree, what are we doing? We are based upon the entropy and your information gain, we are going to draw a tree. That is what based even a layman, like I told you yes in last class, in your previous classes, like even a human being with no knowledge also can understand it. But when it is comparable to your decision tree, your naive bias is more accurate. Why it is more accurate? Because it is different from your decision tree, because here we have formulas, we go according to the formula so that we get the correct solution for it. Next, you have incrementals. What do you mean by incrementals? Each training example can incrementally increase or decrease probability. Now, when I talk about a pen and a pencil, the probability of pen is more when compared to pencil. When I talk about the engineering students, that when I talk about the kindergarten students, what happens? The pen is less compared to the pencil. Okay, then your standard. What is its standard here? Even when Bayesian methods are computationally intractable, then can provide a standard of what? Optimal decision. We can take optimal decisions, making against which other methods can be measured. This is why we are using your Bayesian classification. After that, I told you we are using Bayes theorem. Now, what do you mean by Bayes theorem? This is the formula for your Bayes theorem. This you have been learning from your intermediate also, your probabilities. P of h of x is equal to P of x by h into P of h by x. Now, what do you mean by x here? X is a data sample where the class label is known. That h is a hypothesis which belongs to what? That x belongs to class C. Next, classification to determine P of h of x. How are you going to determine this? P of h of x, that is what is your posterior probability. The probability that the hypothesis hold given the observed data sample x. When the data sample given, then we are going to do this. Then we have P of h. P of h is what? It's your prior probability. What do you mean by prior probability? It is the initial probability. Example, when x is buying a computer, regardless of what age, income, whatever it is. X might be a student, X might be a old man, X might be a middleman, whoever it is, without any probability, without they can buy a computer. Now, P of X of H, what is that? That is probability of observing the sample X, given that the hypothesis holds. What is that? X will buy a computer. See here, X will buy a computer. Probability that X is 31 to 40 years. That is a middle income fellow. Now, let's see a basic example for this. You all can see a data set here. Now, in this, I have C1 and C2, two classes. Okay. C1 and C2. These are the two classes. C1 buys computer, yes. C2 buys computer, no. Here you all can see in the data set you have no's and yes, whether they are buying the computer or they are not buying the computer. The last one. Now, here data to be classified. What is the data which I want to classify? When X is equal to age less than or equal to 30. Income is medium. Student is equal to S. Credit rating is equal to fair. These are the conditions which I need to clarify. What is the rule now I am telling? My age, X is equal to what? Age should be less than or equal to 30. Income is equal to medium. Student is equal to, yes, he is a student. He should be a student and his credit rating should be fair. If for this condition, I need to use the Bayes theorem to solve the question. Now, to solve the Bayes theorem, what is that? How do I solve it? You all know the formula, right? What is the formula? P of A by B is equal to P of B by A is equal to what? P of A by B into P of now. Is this the formula? Is this the formula correct? Whatever I have written. Now, here you all can see for the first one I am doing the same one. P of buys computer is equal to S. First thing I am checking what? Are they buying the computer? Yes. Now what is the? Yes, I need to check how many of them. Now total how many I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So my total outcome. This is my total outcome. Outcome is 14. Now, how many are the possibilities? Yes, when buys computer, how many possibilities? Yeses are there for me. I need to move to what? The last one. Now, when I move to the last one, how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So, 9. Number of outcomes by total number of outcomes, which gives me what? Total 0.693. In the same way, I am calculating for no. For no, it is 5. So this is my value. Now what I have to do? I have to check the second condition. Now I have checked yes and no. Now I need to check what? If my age is equal to 30, then buys computer. If you all can see the previous slide, what is the first I have? Age must be less than or equal to 30. So that's what I am doing now. Age must be less than or equal to 30. Yes, no. Two conditions I have. If this is yes, this is the value. If this is no, this is the value. Now for age 30. Student, yes. Yes is how many I have. When student is 30 less than or equal to 30, I have only 2. Then if it is no, how many I have? I have 3. So this is the value. Next, what do I have? They have given about the income. Income is what? Medium. When I am talking about the medium, again I need to check with medium. Now my medium, and I need to check whether it is yes or no. For the medium, I need to go to the medium. I need to check whether it is yes or no. That is for what? Again for only less than or equal to 30 clause I need to check. Now, then what is happening next for student? If student is yes, he buys the computer. Same thing for all the 4 things we need to check. What are the 4 things I have? First I need to go with age is less than or equal to 30. Then I have income is equal to medium. Then I have student equal to S. Then I have credit rating is equal to fair. When I am done with all these 3, the last what I have to do is my total, like whatever I have, that all my total is multiplied with everything to get the correct answer. So whatever I have, see now buys computer, yes, yes. Now what are the things I have for yes? Age into income. This all are to be multiplied. Your age, income, student and credit, so that you will get an answer here. The same thing, if it is no, again you need to calculate for that, then you will get an answer. Now you have to know what, whether that possibility is there or not. So what are you doing? The last one here, P of x by Ci into P of Ci. Now what is P of x by Ci? This is your P of x Ci. So now what did you get for S? You got 0.044. This is your 0.044 into Byte's computer. First one into 0.643, which gives you 0.028. Here what are you having? First is your this thing, P of x of Ci. Now what is P of x of Ci? 0.044 into, now you have 0.643. When you multiply, you will get this answer. Now when it is no, what is the no? So now what is the no answer? 0.019 into, you have 0.357. When you multiply this two, you are going to get 0.007. This is what is the answer. This is how you calculate your Naive Bayes algorithm. The formula which you are going to remember is this. P of B by A is equal to P of A by B into P of B by P of A. This is the formula which is very important. You need to remember. Based upon the classified data to be classified, based upon that you are going to solve the problem. This is about your Naive Bayes algorithm. Now, what are the advantages in this? It is easy to implement. Now, you have seen only with the basic probability you have done it. Next, you have it gives you good result in most of the cases. Now, you all can see what is the perfect answer you have got. That only the same data set when I will consider to my decision tree. Do I get it? No, now that would be purely dependent on what your information gain and your entropy. Again, it is again the human mind. Whether it is yes or no, I will be predicting it. So, this gives you the correct answer compared to your decision tree. Now, what are the disadvantages? Here, the assumption, your class condition independence is one of the assumption. With this, what is happening? You have loss of accuracy. Because of the assumption, it is lack of accuracy. Now, when I'm talking about practically dependencies, whether they exist among variables. Now, your dependencies, yes, see example here. When I'm talking about your hospital, you have what? You have patients, their age, their family history or their history, everything comes into picture. After this, again, when I'm talking about patient, again, patient may suffer with fever, cough or any of the diseases, something. So, everything is dependent to each other. So dependencies among this cannot be modeled in your Naive Bayes classifier. So this is all about your Naive Bayes algorithm.